Well, this is Aaron Murakami and Peter Lindeman with A&P Electronic Media from emediapress.com. And today is May 27th, and we're about 4.5 weeks away from the 2014 Energy, Science, and Technology Conference, which you can learn about more at energyscienceconference.com. And today, sitting with us is Mr. Jim Murray and Paul Babcock. And if you had followed the conference last year, you know that both Jim Murray and Paul Babcock gave some of the most popular presentations that we've ever had. Jim Murray's presentation was Tesla's Hidden Discoveries, and Paul Babcock's presentation was actually his second presentation at the conference. In the 2012 conference, he gave a presentation called Magnetic Energy Secrets, and at the 2013 conference, he gave a presentation which was a follow-up on that, magneticenergysecrets.com. The first one, Jim Murray's presentation, is available at teslashidden-discoveries.com, and both of Paul's presentations are available at Magnetic Energy Secrets. Now, the first thing I kind of want to ask is that right through the conference last year, which was last June, the end of last June, you both hit it off pretty well and kind of discovered there was some amazing synchronicities between a lot of the work you guys have been doing over the years, going on these parallel paths for a long time. And do you want to kind of go over how the similarities in both of your guys' work?
Yeah, it made for it was a real serendipitous, Twilight Zone moment there. When we realized we started going over our motor designs and realized the incredible similarity between the motors designs and the concepts, about how to, beat Lenz's law, in balancing, coupling, and a bunch of different stuff. So it really kind of tweaked us both a little bit. In the meeting of the minds, and from that point on, it was just collaboration. So it's made for a really interesting year.
And so your particular motor is the flyback one, which is patented, and you kind of went over.
The patent hasn't been quite granted yet, but it's there.
Okay, but the application is published, and people can read that if they search for it.
And we should be getting that patent. And that was the first thing we built and the last thing we patented, just because of circumstances. So it's sitting there right behind you. But it, we built the thing, and then it's just the same story as Jim's got. You're trying to raise money and show people, and just like talking to bricks. So they were. It was beyond, at the time, it was beyond anybody's understanding. So investment people were dealing with, so, well, what can you do with your switching besides this motor? So we weren't sure, so that was clear back in 2002, 2003. So we started hooking the thing up to regular, DC motors, AC motors, and putting other applications to the electronics, and we just found that we could just do amazing things with inductive devices. And that's where, so we decided we were going to patent our electronics first before we patented the motor. And that's a long, winding story of, we had a lot of great people we had to deal with, and we had a lot of shysters, people trying to beat us out of our intellectual, run off with our patent port. This is an incredible story. Someday I'm going to write a book about it. But so it took a long time to get back to the motor. Before we had the funds so we could apply the patent for it. So 2 years ago we actually, okay, now I get to apply for it. It was one of the most frustrating things I ever went through to get the patent filed on that thing. But now we're pretty close to getting it granted, so we're waiting for the office actions.
Which that motor is actually sitting about 2-3 feet behind me right now.
Yeah.
In one of your several labs where you do this kind of work. And so the motor that you're talking about with the similarities, Jim, would that be your Dynaflux alternator? That has the similarities, or is there like another motor involved?
Well, there are several motors involved in the whole thing, but the one that had the greatest similarity was a device that we refer to as the toroid motor. And Paul and I got discussing motors in general, and we found out that we were both kind of like on the same track. And then I started to explain to him about the concepts of energy resonance as I perceived them from Tesla's work, which is totally different from frequency resonance. And of course everybody politely informs you there's no such thing as energy resonance. So you have to always, either you're in an argumentative mood and you tackle it directly, or you just circumvent the whole issue. I'm so tired of the whole thing, I generally don't get involved. But with Paul, it was genuine questions of real interest, and so I started to explain stuff to him. And that's when he started to introduce the idea of his switching technology. And interestingly enough, in my own research, we had come upon the limitations that are imposed by normal, quote-unquote, electronic switches. And the guy that I was working with at the time, a fellow named Eric, I had told him that I envisioned the fact that electronic switches were not true imitations of mechanical switches, and that's what we needed to do. And so we had actually spent a great deal of time and money on that. Not having found a solution, we put it on the shelf for a while. But then Paul informed me that they had actually solved the problem. So as soon as I heard that, I said, well, heck, there's a bunch of stuff that you and I can collaborate on. And so one thing led to another, and I started telling him about some of the electronic work that I had done. And eventually I lit enough of his curiosity up that he took a plane flight down and visited me in Oklahoma, and I showed him the lab and all of the stuff I've been working on for the past 20 years or so. And it turned into a really neat exchange.
So how was that going down to his lab, Paul?
Man, I was like in heaven. I was just astounded. I was just astounded by everything I saw. The quality of the work, the amazing, the great theory it was all based on. It was all the same thing we do, the same theory. And we've taken our approach and his approach, but it's really all the same theory. So when it comes to how electricity works, it's like twin brothers. We get it. And so the marriage of the two technologies was just, it's inevitable, So I was just utterly astounded when I was in Jim's lab.
So not very many things surprise you anymore, but this was...
Oh yeah. And then it's like, what do you mean you investors left you? What do you mean you've had this sitting around for 15 years and nobody's gave a rat? It's just, what? I was just astounded, Yeah. God, what kind of box of rocks guys you been dealing with, Same kind of box of rocks the guys I've been dealing with for years. But I said, this just will not do. This stuff cannot languish, And so when it's like, especially with the SERPS, I looked it over and he was right. All they had was standard MOSFET type switching, which isn't really true switching. So I says, what this place needs is flyback energy technology, the switching technology. And so we've done some of that recently, and it's a marriage made in heaven, man. The switching fixed it all right up. So we're there, It's like what he calls switched energy resonance. We call magnetic energy recovery, it's all exactly the same concept.
Now, about a week, it was maybe a week ago, I put on YouTube a short 10-minute excerpt out of a demonstration that you had done, Jim, with going from your Dynaflex alternator to the SERPS, which is kind of like a solid state version of that general kind of concept. And then you showed a transforming generator, and in that clip it shows 100 watts roughly is being dissipated at the resistor, creating heat, so much it's about to start smoking, yet only 5 watts are being pulled from the power supply. And that's before you start changing the waveforms, and suddenly it's still burning the same amount of heat in the resistor, and the power supply is drawing negative 30 watts, which means more is going back to it than is being drawn from it. And that's created quite a buzz on the internet in a couple different forums and stuff. I can see a lot of the discussions going on where, it's kind of interesting how a lot of people have a lot of comments about what it is and what it isn't without knowing anything about what it actually is. They kind of already have their minds made up. But in general, just kind of from a layman, the concept of reactive power is not really like a layman's concept, but in those simple terms, it's using something known as reactive power that's supposed to be kind of like this phantom power that doesn't really exist, yet you can actually put it to work and make it do real work.
Well, it's a little bit more involved than that, but let me first lay some foundational work for you. The whole idea of free energy, which is a term that I utterly despise, has given people this notion that under the right circumstances, you just sort of pull energy out of the air or out of somewhere, and you have an abundance of it, and it only requires a small trickle to get it going. And this is the golden calf that everybody's looking for. And frankly, I'm not saying someday something like that may or may not be possible, but right now, that is certainly not what I'm trying to do, and it is certainly not what Tesla did. And so I think the first thing to do is to answer your question by sort of giving a real superficial explanation of what actually happens, and then I'll put in some definition so that you can better identify the terminology. First of all, when you run a load of some sort, particularly a resistive load connected to standard power line, you're essentially drawing power from the grid, and it's going through your device, and then it's changed into heat or light or whatever you're trying to do. And the present belief is that that energy then leaves the system at a rate which is as close to 100% efficiency as you can possibly have. And that's why a resistor is used to generally calibrate the losses in a system, because the belief is that whatever power you put into it is converted to heat at a 100% conversion rate, and that's the end of the ball game. Well, interestingly enough, that's not what Tesla said. And while I can't quote from memory every single thing I read from that guy's work, I can tell you that the stuff I did read got me animated enough to look at it from a different perspective. And I said, well, what if you borrow the wattage that you're interested in using and then have a means of actually sending it back where it came from? What is the net effect on the overall system? And it took me a lot of years to understand how to do that. But basically, what happens is when you do that, you suddenly become aware that there are two types of power. And I'm not talking about kilowatts and reactive power here. I'm talking about something much more fundamental. If you go into the nature of the work involved, that's where you start to see it. So if we look at the activity that's going on in the resistive load, what you finally understand is that you have the total work that's being done, irregardless of which way the power is flowing. If it's flowing from source to load or from load to source, it's going to have to pass through your load impedance, and so it's going to do work in both directions. The interesting thing is that if you're measuring power at the source, now you see a different type of work being done. It's the net work. So you've got the total work on one end and the net work on the other end. And if you do it all properly, the two numbers are not equal, because at the load end, the two activities are added together, and on the supply side, they're actually subtracted. So when you start to realize that this is a possibility, then you start to see, this is what Tesla was talking about when he talked about these hyper-efficient systems it has. He was just making use of the two types of work that are available, and the rate at which you can actually perform these works, and the equipment that he pioneered to make that all happen. So as it turns out, the instruments that we use to measure electrical power will look at the load side as being the total work, and you'll get one wattage reading. If you take and monitor with the exact same meter what's happening on the supply side, you will then see a very separate phenomenon, because you'll see the net reading, which is the difference between the power borrowed and the power returned. And when you calculate the efficiency of the system based on those readings, you will find that you have so-called over-unity. because you wind up with a number greater than 100% if you do it right. But you're not creating anything, and you're not taking any unusual power out of the environment or doing anything really weird. All you're doing is using the same power over and over again and returning it from whence you got it. So I hope that explains it a little bit better. I'm not going to go into too much detail here.
Now, one analogy you gave the other day when we're actually here and saw what is probably the first replication of the SERPS by Paul Babcock, and you had, used your own flyback switching technology using Jim's SERPS concepts, and you gave an analogy about pumping water up a hill and.
Right. Yeah. Well, that's just another way of saying that these concepts have been used over and over again. The only difference is the time frame in which you take advantage of the situation. In the example that you're referring to, I was talking about these water pumping stations, which are used as peaking stations from time to time, and they basically are constituting a large reservoir at the top of a mountain and a pumping station at the bottom of the mountain, and they essentially turn the pumps on and run the water up the hill. And they usually do that in the middle of the night when the power is cheap, and they store it in the reservoir. And then during the course of the day, when they start to have a supply problem, they just release the water from the reservoir, have it flow back down the mountain, and they turn the pumps into turbines and the motors into generators, and they put that power back on the line. There's no mystery in doing that. There's thousands of such plants all over the place. The only thing that I did with this stuff, after a lot of years of thinking it through, was that instead of taking 12 hours as the period of exchange between power going in versus power coming out, we're doing it in milliseconds. But other than that, it's the same concept.
Now, Paul, what is the difference between your switching technology and the switching technology that Jim SERPS was using before you had a chance to replicate it?
See, the difference in there's transistor and semiconductor switching. The only problem is it only works in one direction. It does not handle polarity reversals. It does not become invisible in the circuit when you open it up. So years ago when I started this stuff, started doing magnetic research, I was using mechanical commutators and all this stuff, and I just came down to the conclusion, I says, I have to have mechanical switching characteristics, but I need the speed and precision of semiconductors. And so that was the search. I blew up thousands of transistors and SCRs and components till we came up with a configuration that virtually duplicated mechanical switching. So when we have our semiconductor switches, when you turn them off, they're invisible, they go away. It's like they've just disappeared out of the circuit. So so they're immune to polarity reversals. It's standard transistor, and they have to put bypass diodes and all kinds of things, and transistors never worked with big induction, big magnetics. And, because magnetic energy will fry stuff, it's dV over dt. When that field collapses, it's just classic Faraday, you can get millions of instantaneous watts when you turn the switch off. And then it's in the wrong polarity, the voltage reverses, and so your little MOSFET just blows into little pieces all over the floor. And I know that because I've done it thousands of times.
We can show you the broom.
Yeah, dead soldiers, as we call them. Oh, killed another soldier,
Right.
And so we came up with an architecture to where it reproduced that mechanical switching characteristics. And once we did that, then we could hook transistors to big inductive bodies, huge transformers, lots of induction. And that's how we were able to start magnetic energy recovery. And out of that, when we started playing with big inductors, like it's not in the camera view, but there's one sitting right up here on the shelf. That's a 4 Henry coil. And 4 Henrys, that thing can throw 10, 20 million watts in a couple of microseconds back at you. And semiconductor junctions just die. So we also figured out that we had to be fast, and to make switching transitions. So we we came down to the conclusion that to beat magnetism and actually totally master it, we had to do transitions in less than 5 nanoseconds, which is damn fast. So we created this switching transition process along the way, and that way we could extract the energy out of these big bodies, these big inductive bodies, and get huge amounts of energy built up into them. And then we could extract that energy out. Now that all kinds of different phenomenon, which were all positive, it's what we call reduced impedance effect, and all kinds of things we're able to do that nobody was able to do before. Mm-hmm. So we take these big, like that 4 Henry coil sitting on the shelf, if I plug that into the wall socket, it won't draw a microamp because it's such high impedance. But we hook it up to high frequency drives. I mean, I drove that thing at 400 hertz and reached almost full maximum current against the it's got 40 ohms of resistance, so if I put 160 volts DC on it, it'll draw 4 amps. Well, I can hook that up to 400 hertz and I can get at least 2 3/4 amps through it. And I've had physicists just literally spit at me when, seeing is not necessarily believing, let me tell you. And my answer is, what part of seeing it don't you get? And then they just, you're fooling me, and then they start looking for wires and all this stuff, and I says, it's just the same physics you use. Kirchhoff, Faraday, Lentz, Ohm, Joules. Those are my 5 guys. I never argue. I just tell them, you're not arguing with me, you're arguing with those 5 guys, and if you think you can outsmart them and beat them, go for it, But it's just, so we just took manipulation of electromagnetics to this new level, and that's how we were able to build this motor and all the stuff we do. We just do all kinds of stuff with it, and we've taken power sciences to a whole new level, and so that's why we battled to commercialize it, and now we're working in the Middle East, a lot of places, and we've just done amazing things with it. And so it's a long story. Someday I'm going to write a book,
right?
And that's what that switching did.
Okay, so Jim, what really got you started in collaborating with Paul, and how did that take place?
Well, we had a lot of long telephone conversations, but as you know, there's only so much you can convey over the phone. So one day I just said to him, how about if I send you a couple of videos to look at? And I don't remember, how many did I send you? 2?
Well, it was the whole Japanese thing.
Oh, I sent the Japanese thing first, yeah.
Mm-hmm. Beginning to end, and then there was the Dynaflux and the SERPS and the
transforming
generator, and my jaw hit my chest, and I was just astounded at what I was looking at, and especially the SERPS. That just utterly astounded me at what, because I know Jim knows how to measure power, and I'm looking at his test equipment. Quality power, a guy that knows his physics, knows how to measure power. He ain't fooling this is no con job, this is the real stuff, the real deal. And for the life of me, I couldn't figure out what he was doing. Mm-hmm. And so, he explained it. It actually explained some of it to me, and it made sense, but the waveforms and stuff just frickin' blew my mind, and it mm-hmm. took me a while to really analyze the waveforms. I said, Jim, first chance I can get, I'm coming down. And I'd have been there the next week, but you know how it is when you're running a company. And mm-hmm. So it took till almost Christmas before I could get down there.
And the conference was at the end of July, so
yeah,
that was
exactly.
Another 5-6 months or so.
So in December, I found a window and bought a plane ticket and went to visit Jim, And so we hung out in the lab for 3-4 days there, and he let me totally back engineer the SERPS, take it apart, look at it, analyze it, and he had a really good scope like we use, and I just was astounded at what I discovered, and that's when it was like, and he says, wow, you're the first guy in 15 years that's ever figured it out. And I go, well, why? It's so damn simple, it's so freaking, and it was exactly the same, what we do. You don't need any esoteric theory. It's all right there staring us in the face, and the laws we know about that proves that mm-hmm. the Newton's third law does not necessarily and always apply to electromagnetics. And that's where the whole bugaboo lies with all the naysayers, is they stuck Newton's third law to electromagnetics in every situation, and that's a trap. That's what I call Maxwell's tyranny. If that's all you configure magnetics, that's the only result you're going to get. Well, here was totally different configurations of manipulating and controlling electromagnetic phenomena. And I've always said and it was just right down all, Tesla had it down. And how Jim, the way he had done the thing was so innovative by totally doing things in quadrants rather than cycles and half cycles. It just blew my mind. Because I know how to measure power. I've been doing it my whole life, my whole working career. So I knew that this is real stuff. Then I also deduced this needs flyback switching. We combine our switching with this concept and it's off to the races. And we did it. So when I got back, I had all my data, and it took me, work exploded, so I didn't get to it quite as fast as I want to. So over the next 6 months, I built a prototype with in fact, this switch right here, I took it apart, some of our old prototype stuff, reconfigured it, built the driver board, designed up a driver board and built it. And it took me a little bit of troubleshooting, but all of a sudden, poof, there it was, the SERPS waveforms, and, called up Jim and, said, get your butt up here, man. We got some things to do. So first chance we got together here, and then over the winter I talked him into us doing a co-presentation at the conference. So,
which is coming up here in 4.5 weeks.
Yeah, and that's why. So we've been working on our presentation, but what we really want to do is with Tesla. The brilliant mind he was a really smart guy, and he really presented stuff to people like a patent lawyer, where you have to be skilled in the arts to know what he's talking about, which is very few people. And that's why so much of his work and what he's saying has been languishing. And so Jim really is the guy who really deciphered this, the guy who really needs the credit. I remember looking at all these photographs of Teslas with all these big commutator systems, switching commutators, but there was no explanation. What is that experiment? What is he doing? And nobody knew. But he wrote it and he said it. It's just if you're not skilled in the arts, you can't decipher it. And the other thing about Tesla is he was a pre-voltage guy, or pre-electron guy. So all those early experimenters, that was completely long before electron theory. And so they expressed their theories and stuff more in fluid dynamics. And when you understand that, it's a lot easier to decipher what he was talking about. So, over our lifetimes, we actually got skilled in the arts enough to decipher Tesla. And that's what Jim did with the SERPS. And Tesla was saying there's power in the current, reactive power. Scientists laughed, but his terminology got warped. Steinmetz, GE, all those come along, they wrote the books, and they really, all that old terminology that meant different things to those early guys got turned into something completely different. So our definitions of the words are different than the definitions they actually meant.
Yeah, I started that down that line of communication in 2006.
Yeah. And it's true. It's a fact.
Well, a good example of that is if you just talk about inductance. Nowadays we measure it in joule seconds per coulomb squared. No, joule seconds squared per coulomb squared. And the interesting thing is that Tesla measured it in meters or centimeters. And so, when I was trying to decipher his work, I'm saying, what on earth does that mean? And it forced you to go back and research really early stuff to see what the heck the relationships were. And, in those days, they were actually banking on the relationship between, for lack of a better term, magnetic inertia and the properties that it had in circuits, and then take that to the next step and add mass into the picture. And, you start to get a very, very different picture of the way they looked at this stuff. But the whole concept of reactive power, the way Tesla envisioned it, actually came very clear to me years ago, and I read this one amazing book where he was being deposed in a court case, and he was talking about how he actually powered his transmitters. And two very interesting things came out of that. First of all, the attorney said to him, and it's right there in print, so I understand that you have made the statement that you can power a 10,000 watt transmitter with only 2,000 watt input. And he says, so obviously you're talking about instantaneous power. And Tesla said, oh no, he said, it's very, very much continuous power, which of course is a mind blower. He did not say anything else. So that would have been enough to blow anybody's mind in those days. And then the other thing, of course, that came out of it was years ago, I started wondering about the magnifying transmitter and how that operated. And the thing that bugged me more than anything was the third coil, the mysterious third coil. And it took me years to figure out what that thing actually does. And I've had conversations with Eric Dollard, with Guy Obolensky, with all kinds of characters, and everybody had a different opinion of it. So I came to the conclusion, after a lot of meditation, that it had a very singular purpose, and that if I was correct in my understanding of it, I should be able to do something really unusual if I duplicated some of his descriptions in the narrative. So, at great personal cost, time-wise, and with money provided by Josh Reynolds, of all people, I actually built a device which produced the mysterious Tesla wave. And once I saw what that did, everything fell into line. And I'm not going to elaborate on that because none of that is patented, but I can tell you that all of the SERPS stuff and all of the Dynaflux stuff and a lot of the other stuff that we haven't even talked about actually flows from that understanding.
So the SERPS is SERPS, and that stands for Switched Energy Resonance Power Supply?
Yeah, Switched Energy Resonant Power Supply.
And so the origin of the, I guess, inspiration for that solid state model is the Dynaflux alternator?
Oh yes, because that, I had a very profound experience in Michigan. It was one of several during my lifetime. The first one was actually in Connecticut. But the one that I had in Michigan literally gave me a vision of what was possible to achieve if you understood the use of a non-circular armature. And so it took me years to understand what that was all about, because it's anything but obvious. And once I realized what it was about, that's when my understanding of so-called energy resonance came into the picture. And the reason why it's difficult to understand that is because you're talking about optimizing the exchange, a periodic is the word I was looking for, a periodic exchange between one or more types of energy that is also optimized. And that's very difficult stuff.
So what, just for the lay person, you're talking about exchanging energy between an electrical resonance phenomena and a physical resonance phenomena, for instance.
Well, yeah, for instance, like an electromagnetic effect on one end and a mechanical effect on the other, or a strictly electrical effect on one end and a mechanical effect on the other. Most of that stuff is deliberately taken out of the loop when you design normal motors and generators, because they all work on average values, average magnetic value. And I did just the opposite. I wanted to see what the effect was that forces have when they are brought to their peak values. And it was a result of playing around with that stuff for a number of years that I finally got the idea. And then I realized I'm not even equipped to analyze the math, because you're talking about second and third order differential equations that have, you know, non-constant features in them. They have oscillating components in them that require matrices and other advanced things to solve. But I ran into a guy in Pennsylvania when I was working for Piasecki Aircraft Corporation, And he said, "Oh, is that what you're trying to do?" He said, "I just happen to be good at that." So, so we spent a lot of years together until we got the Dynaflux thing pretty well figured out. And then I said, well, I guess the next thing to do is to find somebody that wants to invest in this, and we'll start building them. And couldn't find a soul. So for the longest time, it just sat in my basement, and I used to run it for my own amusement. And then it dawned on me one day that I should be able to duplicate that principle in electronics, simply because if it's truly an expression of physics, it shouldn't make any difference what realm I decide to make it operate in. And at the time, I knew a guy who was an ex-Navy SEAL, and he had worked on some fantastic stuff for the Navy Department, and he was more or less unentangled from or disentangled from the Navy Department. So he helped me build the first one, which was tube powered, because this went back so long ago that they didn't have the necessary electronics available at that time. And the first time we fired it up, it just did some weird things in his apartment. It browned out about 3 or 4 different apartment complexes, in his area. So we said, well, I guess we better tone that down and find a more benign way of playing with that. But that was actually the first SERPS unit, and that was 30 years ago.
Wow. Now, you played around with some mechanical or brush switching in your explorations of moving in that direction?
Oh yeah, but that was long before we built the tube thing.
Uh-huh.
Yeah, because I've been a machinist since I was about 12, and I had a lathe and a milling machine and all that kind of stuff in my basement. So I thought, well, the easiest thing to do is to just use, ordinary mechanical commutation.
Commutation, yeah.
Played hell with arcs and all kinds of stuff,
Mhm.
but it taught me enough to know that that's not the best direction.
Spark machines.
Spark machines, yeah. Well, I mean, a lot of the Tesla's commutation systems that you see the pictures of with all these triangular lines and all this kind of stuff, these were where he was starting to look into pulse width modulation and all this kind of stuff with mechanical switching. And it's just,
That's
I mean,
all we had.
he invented PWM, and people don't even know that.
Yep.
Exactly.
And so, yeah, it's just amazing.
Now, here in a couple days, we're going to be releasing a package of, it's going to show the so-called Japanese demo where it had the Dynaflux alternator demo, the SERPS, and the transforming generator in there. And we're going to be giving an older presentation, which is just kind of a free bonus we're going to throw in there, which kind of hard to see some of the pictures. It looks like it's on a television screen behind you, and it's kind of dark. And but
The information's A1, it's great.
but you can obviously hear it pretty well,
Yeah.
and the explanations are pretty good. I mean, as far as the audio goes, the pictures are a little bit dark, but you can see them good enough to tell what's going on. And we'd recommend, or at least I'd recommend somebody watch that first before the Japanese demo, because that kind of gives more of the background on it, and then it walks into the demo. And is there anything you can say about that other video? That
was the one you gave it for Stephen Greer.
Yeah, that was the one that Stephen Greer did of me. It was done in Washington, D.C. a number of years ago. And believe it or-
2007, I think it was like December 2007 or something like that.
Yeah, I honestly don't remember,
Yeah, right.
but if that's what it was, that's fine. But believe it or not, I've never seen it.
Okay, we'll get you a copy.
We'll give you the link, you can download it.
But I do remember the approximate approach I took,
Yeah.
and it was all about the various types of research I had done earlier,
Right.
how it led into my thinking and all
Right.
that kind of stuff.
Well, I think what the advent of that talk is that you were slated to give that at the end of July in 2007, and you were there, and they cut you off in the middle saying we have to get back on schedule.
Oh.
You were so bummed out. You were so mad.
And then there was another individual, I won't mention any names, who talked for an hour and a half after me about an underground house.
Yeah.
And I said to myself, if that's what you want, that's what you'll get. And I have turned their invitation down religiously ever since.
I was in the audience, and I just about stood up and said, no, don't stop. But, you know, it's just, in a room with 300 people, you don't,
Yeah.
it's too crazy, but I just couldn't believe it. And then you were swarmed. I was going to come over and say hi, and then you just stormed out and left, and I never saw you again. But that was just a wild story in and of itself. So I'm glad you actually got to be able to give the whole talk to somebody, even if it was on a television.
Well, I also gave an updated version of that last year.
Exactly. Yeah.
Yeah.
So Tesla's Hidden Discoveries is really, you know, an updated version with we made the images a lot clearer to see and everything else, and that's.
And it's
But
more
the
or
thing
less
is your commentary on that original one actually covers some territory that isn't in the new one, and I think they're both worth seeing.
Yeah.
Both.
And I would say that where you're giving the 3 different demonstrations plus that other video would probably be a good primer for anybody to be able to watch to kind of prepare themselves for the presentation coming out,
Absolutely.
which you and Jim are going to be, you know, giving at this upcoming conference at the end of June.
Yeah.
Yeah, I think we're gonna really open up some minds, or hopefully that's the goal, and really explain to people how this stuff really works.
So what would somebody hope to be able to learn from the presentation? Like, first of all, getting their definition straight of what, you know, to be able to define the
My
terms.
biggest thing is to get people, especially the science community, to break out of their, you know, they're like puppy dogs tied to a chain, and to expand their belief system. They're just in a box, and that box is Maxwell, and I have nothing against Maxwell himself, but what was done to his work, I have something serious against, and that Mother Nature uses Newton Third's law with electromagnetics to create a balance. And that's how Mother Nature does it. But that doesn't mean we have to do it that way. And when we it's like going up to a diesel engine and tweaking the governor so the governor no longer restricts the engine. And that's what we do. We learn how to prevent magnetism from clashing with itself. And so it all boils down to this. And all the free energy research, everybody's looking for the magic equation. Well, the truth about, you know, I hate this term over unity and free energy too. The truth about it is what you're looking for are mathematical expressions or inequalities. Because if it's equal, it's the same.
Talking about the net on the input compared to what you're actually measuring at the load.
And so the mathematical expressions have to say this is more than this. And we have all the proof of physics you could ask for to prove that. So there will be some basic math in there, and there will be an explanation of how the known laws of physics were already used, which is I've pretty much done. It's kind of a continuation of the last two. We have all these known laws. If you use them differently, you get incredible results, and you don't have to go off into esoteric theories. You know, I like, you know, 0-point energy theory and all that, but
Who needs it?
who needs it? Exactly. Who needs it? It's all right here.
Yeah.
You know, I mean,
By the way, when he says, you know, he's not saying he's changing the laws or using the laws differently or incorrectly. He's just using them in situations that you normally wouldn't think of if you thought only in a very small way.
exactly.
Yeah.
If, you know, because you can't look at things as immutable, you know, it's the same laws. You know, Maxwell expresses a configuration, a physical configuration. If I take two magnetic fields and I clash them together, you're going to get drag force.
Right.
So like what's so cool with the SERPS machine and all these concepts, and it's like what we do with our stuff, is if you're making electricity, alternating electricity, that means you have to have horsepower. Solar panels and batteries are a little different, but in the grid system, that means magnetism is causing drag forces, which must be overcome with horsepower. Well, when you take and you borrow some force from that motor and you cause drag force, you use the electricity, and when you put it back, it becomes motive force. So motive force cancels out counter motive force, and the torque and horsepower you need goes way down because now there's less load on the motor because I've canceled out the drag force with motive force, but I made work both directions at the load end. So now suddenly my generator doesn't have near as much drag in it, so I'm burning less fuel, and my power output at the load has gone up. So that just blows, that's what I'm saying. It's a different configuration than the clashing of magnetic fields. We're learning how to interlace energy back to the prime mover source. And so guess what happens to my fuel consumption on a generator that I'm doing this with? Now I'm getting all my lights lit up for just a little sip of fuel instead of gallons of fuel every hour. And it's just factual. You can't argue with it. It's just the same exact laws of physics. It adds up. We're proving it with the SERPS. We're proving it on our machines. It's just, I get tired of arguing with people, you know. So it's just the way it is.
So at the upcoming conference at the end of June, which all the information on the conference is at EnergyScienceConference.com, I would imagine that this is probably going to be maybe the most important or revealing talk on the concepts of so-called using reactive power as energy compared to anything else out there. Because there's nothing out there that's
First of all,
really...
nobody's even talking about this subject.
This is all, I've watched all the stuff, and that's why I've stayed off the forums and the internets and all that, because so much of it's all a rehash of the same old stuff. Well, this is a culmination of 2 lifetimes of work that have just, you know, it's like, I knew I had a good handle on it, but when I went down and took the SERPS apart and played with Jim's stuff, it was just like all of a sudden the last bit of the fog was gone. You know, it's clear to me exactly how it works. I don't even have to think about it anymore, and I know where to go in the development of this technology. And I have this belief that Tesla was every bit a prophet as much as he was an inventor and a genius. You know, look what the man gave us. Known as later life, Tesla's lament was, well, the bankers and industrialists have taken my work and made this century theirs. But he goes, but I tell you, the next century will be mine.
Yeah, the future
and that's
is
what I'm
mine,
about.
right.
This is going to be the real Tesla century. We've uncovered what he was telling us. We've opened up a whole new world of science and application. And it's going to happen. It's happening now. And that's what I came to this world to do, is to advance humankind and to bring this stuff to fruition. And, it's just going to happen. And, I've given many a PhD an intellectual beating, and I'm not adverse to doing it some more if I have to. So that's how it goes, But I'm not taking any prisoners. We're not slowing down. We're not in a bag. It's just going to happen. And if we can engender public support and open minds, people's minds have to open to the concept. They have to throw off the old conditioning, especially with electrical physics. And the more people that do that, it builds up more. It's logarithmic. It builds up more momentum. It opens people's eyes to the possibility. They start realizing it's a factual route, and then that will drive the process further.
And do you have any final comments or words of encouragement or suggestions for everybody out there that's going to be watching this interview?
Well, Paul and I were discussing something along those lines just yesterday, and I think it's important to relate the following. The whole thing with people who do independent research has been, for the longest time, keep your information to yourself, race down to the patent office at your earliest possibility and get everything squared away in your name, and then sit around totally paranoid while you're waiting for first office action. And the irony of all of that nonsense is that you actually play right into the hands of certain individuals who don't want any change. And while I'm still required to patent stuff for my own protection, and so is Paul, I think that the other lesson that we need to get from this is that intercooperation and opening your ideas to each other and sharing stuff in the long run is probably a lot more valuable than hoarding the information and hoping for the best. Because if you follow that route, you're going to get one incredible screwing. We'll leave it at that.
Well, thank you, gentlemen. This video will be online shortly, and hope everybody enjoys this, and we'll look forward to seeing the presentation at this upcoming
Yeah.
conference.
See you at the conference. It's going to be the best one yet, I got a feeling.
Yep.
Thank you. So we eventually figured out that it's the switching time of the power that is most critical, and that is achieved in lots of different ways. And this machine is done mechanically, or it can also be done with electronic switching.
その電気の切り替え、スイッチする時のタイミングが重要なので、機械式にもできるし、その電気式にもできるということは分かったと。
Oh, here's the results to that if you like to keep it. So, as you,
そうですね、こっちはね。
in the original one that we showed you the first time in this room, the little tiny one, it was only capable of handling about 30 watts. We had more trouble with the switching arrangement than that it was very, very difficult to scale it up.
そしてその30ワットからスケールアップさせて、そのなかなか難しい問題があります。
Since that time, Eric has developed a new control module and a new switching module, and we've had a larger set of capacitors to store the energy.
This is the control,
Yeah,
and this is the switching,
switching, right.
and this is the capacitor to store energy.
Yes.
エネルギーを貯蓄するキャパシターと新しいスイッチと新しいコントロールパネルをそれあれ以外開発して
So these segments are all new. The one that we showed you before was a little tiny computer-driven model,
これはもうですから新しい前回お見せしたものとは違います
and this one is much more flexible, and it allows us to control the wave function geometry, which in turn gives you the resulting change in efficiencies that we're going to show you.
この機械は非常に高い能力がありましていわゆる電波の波形まで変えるでそれが結局そのより優れた効率につながっていく
Now, we have it set right now to imitate approximately the results we gave you the first time.
これ今ですねどこにセットしてるかというと前回お見せしたものと同じようなところにセットしてあります
So, in this resistor, which is the load now, we are dissipating about a little less than 32 watts.
これ前回32ワット
From the
前
line,
回と同じところにセットして
from the line, we're pulling almost 11 watts, 10.97, 10.98 watts. Now, what we're going to show you is, and the reason I have the scope on here is so that you can watch the waveforms change in accordance with the changing efficiencies that we're going to show you.
効率が変わるたんびにこの波形が変わってくるんですよ
Eric, you want to take over and the first thing we ought to do is probably bring it down.
まず下げます
Now what he's doing now, if you watch the waveforms changing, you can see that the geometry of the waves changes in accordance with the results. We are now dialing down so that the input power is only...
It's all the way down for the current setting I have.
Okay, so right now we're only pulling 1.5 watts from the wall, and we're still giving you 33 point...
今1.5ワット壁から1.5ワット取ってでもこっちが30ワットだ
But we'll leave this setting fixed for the moment. Eric, crank it up. Now, we're going to show you that we're not limited anymore to 30 watts.
だから30ワットじゃなくて今度はね100ワットも出せると
So now we got 100 watts in the load, and we're pulling 5 watts. That's 2,000%.
電源が5ワットでこっちが100ワット出て
The resistor's going to get pretty hot.
Yeah, we can't leave it on too long. It'll smoke. But you can put your hand on there. It's bloody hot.
これは実験機ですから熱くなっちゃうんでそう長くは置いとけませんけども
それが負荷でしょ
そう負荷です
なるほどね。
負荷のキャパシタ
Now, we have one other little thing to show you. and it's pretty startling. If you continue to change the waveforms appropriately on this, due to the way that these capacitors are made to operate with these switches, we can actually send back more current than we take from the line. And that results in these wattages going negative.
今度はですね、
Oh my God.
逆にね、あっち
Oh
に
my God.
電波を送り返すことができる。
So that meings we are still dissipating 102 watts in the resistor, but we're sending back 30 watts to the power company.
100ワット使いながら、なおかつ30ワット向こうの壁の方に電源に送り戻してる。
Now, the implications of that, if we can marry this with even your standard wind generators right now, the power that's going back will help it to turn like a motor and you'll operate with less wind.
That's one of the applications. For starters.
発電してるからですね、さらに羽をこう回す。
Well, it's
力
kind
になる。
So now question in relation
こっちの自風でも動くようになる。
in relation to the mix you're getting from the grid.
Yeah, it's starting to smoke. Turn it down a little.
In relation to the mix you're getting from the grid, you're getting reactive energy and
No, see, this is, well, yes and no. You have to understand that in a normal situation, reactive power is defined as a form of restorative power in which the average value is zero.
correct. Yeah.
The problem with that is that the current and the voltage are usually out of phase by 90 degrees, which means that you can't use it.
Right.
What this device allows you to do is to create watts that are doing the same thing of going back and forth. So the wattage becomes reactive.
Gotcha. Wow.
See, here's the thing. In Japan, average wind is like 2 meters. So if we could bring it down to the circle, we can rotate up prop by 1 meter wind. That makes a huge impact.
Yes.
Well,
That's possible.
as soon as we have the funds to do so, I would like to get a standard alternator that you guys use, or whatever kind of generator you use, and try to marry this system with that, put the instruments on it to see how fast it's turning, and then see what the effect is.
Now, what effect? Let's say on a global scale, on a large scale. Say there's 100 million units like this in America. What effect would that have on the grid?
Okay, that's a very interesting question, and I know the answer to it because I researched it thoroughly. Tesla himself said 100 years ago that if we used reactive power
Right.
instead of the normal kilowatts,
Right.
and he was referring to reactive kilowatts, not
Right.
the normal reactive,
Right.
that our present transmission grids could bear 1,000 times the load that it can sustain right now for exactly the same fuel consumption. And that's not an exaggeration.
But the question was, the effect of this on a global scale with 100 million units in America, everybody having one of these, what would happen to the grid?
今質問ね。もし各家庭にこういうのがアメリカ中に入ったとしたら。The answer was?
And the answer is that Tesla's predicted 100 years ago that if you did this judiciously, and everybody was returning the majority of the power they're using back and forth, that the same grids that we use now, the same generating facilities that we use now, could sustain 1,000 times the power that we can deliver now for the same fuel consumption.
100年前ですよ。もしこれを各家庭に持たせたとしたら、
We've been ripped off.
その配電装置と発電装
How do you meter it? That's where Tesla got killed.
Well, no, you meter it the same way. The problem is it changes the economics of the thing drastically. So, that's why J.P. Morgan said, pardon me while I pull the plug.
Yeah, right.
But if we get to the point in the world where this is the way to go, there has to be another means of reimbursement for everybody.
Totally.
あんたにお金あげるってやめちゃって行かれちゃったら。
Besides,
You
those
see, the
infrastructure
most-
paid for long ago.
The most important thing that we learned from this, guys, and you have to understand this, is that when the traditional power measurements are made,
Right.
and everybody says, okay, if we hang a resistive load directly on an alternating current source,
Right.
that is the closest thing we can come to 100% efficiency. Because I measure, let's say, 100 watts here, and I measure 100 watts at the source, and you can't do any better than that.
Right.
This proves that there's extra energy there
or I couldn't do this.
That's right.
No, but isn't that extra energy part of the phantom energy, or?
Well, call it what you want.
Right.
It's still there.
It's true.
And what's interesting about it is,
I mean, they know about this, but they just don't know how to capture it or whatever.
well, they don't know how to capture it because their thinking is wrong. But the other
don't know about it because of the actual equation.
I was just going to say, when Maxwell originally was doing his fundamental work on the transmission of energy, he made the assumption that all of the energy was carried only in the electric and magnetic fields, and he did all of his equation work from that.
Right.
Years later, and it was like 30 years later, Einstein, and De Haas, who was another physicist, redid all of these experiments that Maxwell had done at an earlier time, and they found that there was additional energy that was carried by the current itself, not by the fields. And they said, oh, well, it's a fairly sizable number, but we don't want to rock the boat and change all the equations, so they just let it alone.
Gotcha.
But there it is.
That's right.